Angara is a whole family of light, medium, and heavy class rockets with an oxygen kerosene engine, created based on a universal rocket module. The first one to prepare for a trip into orbit was the light rocket carrier Angara-1 PP. The main goal of the launch was to check the engines and rocket systems, including the navigational and telemetric equipment, as well as the proper functioning of the space rocket complex components. The cargo layout mimics the head of the rocket payload, and having passed 5,700 kilometers, it will land in a specified area of the Kamchatka Peninsula. It was here in this spacious, bright room that the most important stage, the final assembly of the rocket, is held. This assembly test body has all the necessary equipment for the independent testing of missile units, its assembly, and subsequent loading onto the transporter. The entire history of the Angara is like a reflection of Russia's recent history. Conceived as early as 1992, the rocket passed through the echo of USSR's collapse, the criminal 90s, and even the economic crisis of 2008. And now the Angara project comes to the finish line, holding its first test start. This is the layout of Angara, but not just an imitation, but a complete missile, able to send a satellite into orbit if needed. Alexander will tell me about its components and the principles of modular assembly. Yes, indeed, this rocket carrier was built according to a modular assembly principle. The rocket consists of a Unified Missile Module 1 and Unified Missile Module 2. If necessary, the missile data modules can be arranged into a light-class rocket carrier, as we see now, and also into a middle-class or heavy-class launch vehicle. Angara-1 PP consists of a first stage, second stage, nose fairing, payload weight layout, and booster. By adding universal rocket modules, URMs, we get a whole range of rockets from light to heavy class capable of performing a variety of tasks for the needs of military and space. One launch pad for light, medium, and heavy rockets, only thanks to modularity. Yes, the system is the same in the starting complex and the processing facility. No changes or additional preparation when changing the rocket would be required. Each URM includes a propulsion system, an instrument compartment, tanks for fuel, and an oxidant. So URM is basically a rocket. That is, the rocket Angara will consist of several small missiles roughly put. Yes, each block can be presented as an independent missile. Angara's universal modules allowed us to standardize the production, and now the cooperation of the Russian enterprises has unified blueprints and technology. This is what ultimately reduces the cost of each startup. The use of Russian scientific and industrial potential protects the Angara from the political will of other countries. Quite a logical step if we remember that the client is the Russian Ministry of Defense. The lead developer of the missile is the Krunichev Scientific Productional Center, one of the largest branches of which is in Omsk. At the Polyat Industrial Association, URMs are assembled for the Angara. First, they work with a preform for the rocket fuel tank. They mount the technological rings and other accessories for loading and docking. Next, there is a connection of the longitudinal joints by friction welding. Today, this is the most modern technology based on the principle of friction between different surfaces until a complete merger. In contrast to conventional welding, friction prevents thickening. On this machine, all the other parts of the missile, including the bottom of the fuel tank, will also be lapped onto each other using this method. Next, the bottom is welded to the tank, and so we get a tank for the URM-1 oxidant. With the help of technological rings, the tank is turned over to a vertical position in order to check for leaks. This is followed by hydro testing. The space of the tank is filled with liquid, after which they monitor and inspect for leaks. Then the tank is driven into a separate chamber to install the inner tank devices. The sterility and purity of the camera is key to the safe and trouble-free operation of the engine afterwards. The thing is, if the fuel will have technological impurities from the factory, a rocket engine fire is impossible. Apart from inner tank devices, expendable pipe and fuel level monitoring sensors are also installed into the tank. The URM-1 has separate tanks for oxygen and kerosene. After installing inner tank or dry compartment, the engine compartment and the adapter ring for the subsequent installation of the propulsion system are secured. After closing the engine compartment, URM is ready for final assembly. The only thing that remains is to establish a trunk line through which the oxidizer enters the engine. Fuel is poured directly. After being laid down on the railway unit, the URM is sent to Moscow to the Khrushchev Scientific Productional Center, and then, after all the independent tests, it is sent to an unassembled state to the Arkhangelsk region, where final assembly will begin. The military calls this process overload. I fully agree with them. When 18 tons of weight, that's exactly how much a dry rocket weighs, flies over you, you automatically start to feel like a dwarf in the world of giants. At the same time, in order to successfully install the Angara on the conveyor, all work must be completed with a tolerance of less than a millimeter. Already the next day, the combat crew will take the rocket to the launch pad, where we'll pass all required tests and will be prepared for launch. Taking advantage of the moment, we decided to leave the Angara and take a walk along the launch complex. I am at an altitude of 54 meters on top of a huge mountain of steel called the cable filling station. It weighs about 1,500 tons and is used for filling and retaining the rocket. The cable filling tower also performs a windproof function. Even a force 7 wind will not overturn the rocket. It is in this building that the highways of working gases, fuel supply, as well as all electrical cables and information networks are located. It's virtually like a cocoon for a butterfly, but instead of colors, our butterfly is interested in space. I, in turn, was interested in a huge metal platform at the base of the cable filling towers. The device which we are now on is called the launch pad. This is where the launch vehicle is located at the time of launch, along with all the communications designed to prepare the rocket for the launch. The launch pad is the heart of any launch complex. Its metal cladding is like a medieval breastplate weighing 500 tons, protecting the area from jet fire during the rocket's takeoff. None of the plates are fixed and have clearances. This ensures that during the moment of dynamic impact, the expanded metal does not deform. Under the plates, there are several layers of thermal insulation. Are there any measurement devices in the launch pad itself? Yes. There are sensors, measurement systems, and technological equipment in the compartments of the launch pad, as well as in the gas duct and the cable filling tower, which are intended for the measurement of physical quantities such as dynamic effects, vibratory loads, temperature, etc., etc., etc. In general, we get a complete physical picture at the time of startup. The preservation of the launch pad during launch is provided by a direct gas duct with an exhaust gas deflector. During the launch, tons of water for cooling will be pumped there. Next to the launch pad, there is a control station for the fire extinguishing system. There are systems of water, water foam, and halon fire extinguishing at their disposal. 4 masts are charged with water and foam straitjackets to cool the ardor of rockets. In general, are there a lot or a few of launching or propulsion systems that provide the start of every rocket? I can say that Spetsstroj provided the installation of 36 technological systems for the launch complex. This includes the basic cycle preparation system and rocket preparations here on the launch complex. The main systems include a standard filling system, a liquid and oxygen filling system, a naphthol refilling system, a system providing compressed air, which includes both production and filling of compressed air as well as other working gases. There are 3 kinds of gases used here: helium, nitrogen, and air. The versatility of the launch facility allows the launch of light and heavy rockets without adjustment. In the context of military application, for example, when restoring the orbital satellite constellation, launches will be conducted continuously. That is why they are considering the construction of a second launch facility. Every technological complex and building has a backup body that provides not only flexibility but also the reliability of reinforced concrete. The next morning began with the construction and formulation of the problem of transportation of the Angara. The escort service, together with combat duty assignment, took their places according to protocol. Then the locomotive for docking came up. After checking the connection, our train started moving. We ought to hurry. There's less than 57 hours till the launch. It's about 7 a.m. now. I terribly want to sleep, but all services and combat duty assignments are long in place. Together, we'll participate in the Angara's transportation to the launch pad, and I can finally feel like a true space loader. Igor will tell me how the whole operation is going. Hello? Hello? Igor, why are we moving at such a slow speed? Such are the requirements for transportation. The speed should not exceed 5 kilometers per hour so that we can safely transport a product that took a long time to prepare for combat assignments at the technical facility and guarantee it the safe and sound start of its trial. Along the way, we saw a few checkpoints. Each point has everything you need for the emergency repair of the tracks or a stuck train. In the open areas, my glance rested on the fences that hide the way number 1 away from prying eyes. Meanwhile, the locomotive began to slow down its initially not so high speed. This is where the locomotive stops and continues its motion only with the tail compartment forward. The weather began to change for the better. Even the sun came out. At the launch site, the installer must enter first to provide the necessary docking units, and the locomotive could be sent to the depot. The track has a special configuration and is built precisely for these tasks. The position of each track and railway sleepers were measured virtually by hand. Such a load and weight excludes sharp turns. We're passing some sort of hangar. Is it a repository or is it some kind of gate? What is it? No, we've entered the universal launch pad, the starting position. And the first building we encounter along the way is a complex of low-pressure filling tanks for the Breeze M booster block of the Angara-A5 heavy-class space rocket. The construction part is not yet finished. It's still going on in its second stage. And in this case, we have a little tradition at spaceports that has taken root at the Angara as well. In order to commemorate the beginning of some stage of work that's important and interesting, we put a coin on the rails and we press it with the installers. I want to give you such a coin. Thank you. This in memory of this significant event, the transportation of the Angara rocket to its first universal launch facility. Our train was greeted by a large number of people. Military and civilian experts waited for 2 hours for the Angara to appear on the horizon. The Angara's high-speed train is arriving on the first way. Everyone goes to the greeting dock. Next, the locomotive will unhook from the site and the installer will cover the last 4 meters with the help of its own electric drive. The most important part of the transportation is the docking of all electrical and hydraulic power units with the launch system. To do this, the installer reaches the control points and makes runs over the carriage of the automatic docking unit. This completes the transportation process. But this is only the first step of a ladder abutting straight into the sky. There was a serious operation ahead of us, installing the rocket on the launch pad. The power supply must be installed manually. I was even entrusted to connect the power cable. I am now connecting the power supply. You need to Get it right into the grooves. One, there it is. Power's connected. After the installation of the power supply, the installation of the rocket on the launch pad begins. All operations are occurring in a normal mode, which means everything is controlled automatically. Before the lifting of the boom with the Angara, the installer itself rises above the rail by using 2 hydro bearings. The boom is set in motion and 4 telescopic hydro cylinders begin to lift the precious cargo. The operator monitors the process from the command post with the help of angle sensors and limit switches. The whole construction stops itself after reaching a 90-degree angle. Next, the installer frame drops due to retracting hydro bearings. The missile assumes a vertical position automatically thanks to free flow of fluid between the hydro cylinder grippers near the tail section. As a rule, the rocket will stand motionless and under its own weight thanks to the design of the starting system and the 4 thrust bearings on which it rests. In addition, further service platforms are added acting as containment booms. Next, the combat squad will only need to dismantle the removable elements of the missile, connect the contact lift electrode connectors, and breathe a sigh of relief. After the installation, a 3-day preparation cycle for the start begins. Brigades of assemblers consisting of those who work in the aerospace and defense industry together with civilian specialists decorate the rocket like a Christmas tree. Only instead of Christmas lights, they use refueling systems, power systems, and communication systems, as well as systems of thermostatic control that maintain a certain temperature inside the rocket. They must also ensure communication with the automated launch system, as well as the pipelines for oxygen, nitrogen, and helium. Having left the Angara for preparation, we decide to find out where are all these gases actually stored. Prior to the start, the rocket is monitored by the measurement tools of the spaceport, but as soon as the Angara lifts off the ground, it will be under the control of the Tirov Main Test and Space Systems Control Center in the city of Krasnoznamensk. However, Plisietsk will continue to work with the missile, broadcasting coverage of the hardware-software complex to the joint staff of the armed forces. Space control stations accompany the Angara during its entire flight. At the last moment, the rocket stands under its own weight with the retention pads put to the side. 3 and 60, control parameters normal. Starting the first stage engine. Go, contact lift. Flight steady. Rotation start, flight is steady. Trajectory close to its estimates. 30, control parameters normal. First stage, engine functioning normally. Rotation finished, go stabilization, flight sustainable. Trajectory close to its estimates. Smoke, fire, and the Angara cuts through the sky. The launch was successful, and within 200 seconds, the rocket will leave the atmosphere. From this moment, we can officially consider the Russian space program independent. After contact lift, the engines work according to the pre-installed program. The cyclogram of the flight says the Angara will continue to gain its predetermined elevation while performing the necessary maneuvers. At 98 kilometers, the first stage boosters detach and fall into the southern part of the Barents Sea. Then comes the second stage boosters with the nose cone as the rocket reaches the Earth's surface at an elevation of 200 kilometers with a Mach payload. This value corresponds to a low orbit used for military purposes. Land clearance ends after 500 seconds and the rocket falls according to a suborbital trajectory on the Kora landfill in Kamchatka. Undoubtedly, we are obliged to continue the traditions laid forth by Sergei Pavlovich Korolyov in order for Russia to remain a great power in the space program.